What happens if you can't open your eyes for just one day? Not asleep, not blind, just sealed shut. From the moment you wake up until the moment that same clock ticks around again. Let's set the rules first. No peeking, no cheating. 24 hours, completely in the dark, while everything else about your life keeps moving. Sounds simple, doesn't it? Close your eyes, wait it out, open them again. But your brain does not agree that this is simple. Let's find out what actually happens. Start with the first few minutes. You wake up and for a moment, everything feels normal. Then you remember. Eyes stay shut. You reach for your phone out of habit and realize you have no idea where it landed on the nightstand. Small thing, except it isn't. Around 80% of the information your brain processes about the world comes through your eyes. Take that away, and every other sense doesn't just get slightly more important. It gets promoted, immediately, without warning, into a job it wasn't built to do alone. So what takes over first? Hearing sharpens almost instantly, but not because your ears suddenly get better. Researchers studying sensory substitution have found that the brain reallocates processing power, redirecting neural resources that would normally handle vision towards sound and touch instead. It's less like upgrading your hearing and more like giving it the entire building your vision used to occupy. Within the first hour, sounds you'd normally tune out, a fridge humming, footsteps 2 rooms away, become impossible to ignore. Now raise the stakes. Try walking down a hallway you know by heart. You'd think muscle memory alone could carry you. It can't, not fully. Balance depends on a 3-way negotiation between your inner ear, your muscles and joints, and your eyes, constantly cross-checking each other to keep you upright. Remove vision from that negotiation, and the other 2 systems have to work overtime, correcting for a wobble your eyes would have caught instantly. Studies on postural control have shown that removing visual input alone can increase body sway by well over 50%, even in people simply standing still. That's not clumsiness. That's your nervous system quietly panicking in the background while you're just trying to find the doorway. Here's where it gets stranger. By the 2nd or 3rd hour, your brain doesn't just adapt, it starts inventing. In 2004, neuroscientist Alvaro Pascual Leone at Harvard ran a now famous experiment, blindfolding sighted volunteers for 5 straight days. Within about 48 hours, several participants began reporting vivid visual hallucinations, shapes, faces, flickers of color, appearing out of nowhere. Their visual cortex, starved of real input, didn't go quiet. It started generating its own imagery to fill the void. This isn't unique to lab conditions either. People who lose their sight later in life sometimes experience something called Charles Bonnet syndrome, first documented by physician Dominic Ficci and colleagues, where the brain conjures detailed, often bizarre visual scenes despite receiving no visual signal at all. Your brain, it turns out, does not like an empty channel. If you don't feed it images, it will make its own. So somewhere around hour 6 or 7 of your blackout day, you might start seeing things that aren't there. Faint geometric patterns, a flicker of light that isn't real. It's not a hallucination in the dramatic, disturbing sense. It's your visual cortex, one of the most metabolically active parts of your brain, refusing to sit idle. But the physical toll goes beyond illusions. Simple tasks that took seconds now take minutes. Pouring water into a glass without spilling. Finding a light switch, buttoning a shirt. Each one demands a level of concentration you never had to spend on it before, because your brain is now cross-referencing touch and memory to build a mental map that vision used to hand it for free. Occupational therapists who train people adjusting to vision loss report that this kind of task-by-task relearning is exhausting in a way that's hard to describe until you've lived it. Not physically tiring, cognitively tiring. Your brain is running a marathon it usually outsources to your eyes without even noticing. Then there's the part almost nobody expects. Time distorts. Without the visual cues that anchor your sense of a day passing, morning light fading into afternoon, shadows shifting across a room, many people who undergo extended blindfolding report losing track of how much time has actually gone by. Some researchers studying sensory deprivation have documented participants misjudging elapsed time by wide margins, sometimes believing hours had passed when it had only been minutes, or the reverse. Your internal clock, it turns out, borrows more from your eyes than most people realize. There's also the question of sleep itself, which gets stranger than you'd expect. Your body relies partly on light hitting specialized cells in the retina to regulate its circadian rhythm, the internal clock that tells you when to feel tired and when to feel alert. With your eyes closed for a full day, that signal disappears, even though you're technically still capable of sensing brightness through your eyelids in a limited way. Some people report feeling drowsy at odd hours, not because they're actually tired, but because the usual light-based cues that normally suppress or trigger sleepiness have gone quiet. Napping becomes tempting in the middle of the afternoon for no clear reason at all. Smell shifts too, quietly, in the background. It's not that your nose gets sharper in any measurable biological sense over a single day, but attention works differently once vision stops competing for it. The smell of coffee brewing 2 rooms away, laundry detergent on a shirt, rain outside a window, these become noticeable in a way they weren't before, simply because there's nothing pulling your attention elsewhere. Combined with sound, smell starts filling in details your eyes used to handle instantly, like knowing someone just walked into the room before they say a word. And then there's the social side of it, which almost nobody thinks about until they're living it. Conversations change completely. You can't read a raised eyebrow, a half smile, the subtle look that says someone's joking before they finish the sentence. Communication researchers who study nonverbal cues estimate that a significant portion of the meaning in face-to-face conversation comes from expression and body language rather than words alone. Strip that away for a day, and even a simple conversation with a close friend starts to feel like reading a book with half the pages missing. You lean more heavily on tone of voice, pauses, the exact words someone chooses, details you'd normally never have to consciously track. And your emotional state shifts too. Around the 12-hour mark, many participants in blindfold studies report increasing anxiety, not from any specific threat, but from the accumulated effort of navigating a world that no longer confirms itself. Every step requires trust, that the chair is where you left it, that the stairs are where you remember them, that nothing has moved. That constant low-grade uncertainty adds up. Some people report the opposite too, a kind of forced calm, because panicking makes everything harder to navigate safely, so the brain, out of necessity, learns to slow down and stay deliberate. By hour 18 or 20, something else kicks in. Touch becomes almost hyper-detailed. The texture of a doorknob, the exact temperature of water from the tap, fingertips, already packed with more touch receptors than almost any other part of your body, start doing work your eyes used to handle at a glance. Some blind and visually impaired individuals develop this sensitivity into extraordinary skill over years, like Daniel Kish, who taught himself to navigate using click-based echolocation, reading the shape of a room through sound bouncing off surfaces the way bats do. In a single day, you won't develop anything close to that level of skill, but you'll get a small, humbling glimpse of how much information exists outside of sight, information you walk past every single day without noticing it's even there. By this point, you've probably also built something else entirely by accident, a mental map. Every room you've moved through gets stored, piece by piece, as a rough sketch made of distances, turns, and remembered obstacles rather than a picture. Cognitive scientists studying spatial navigation in blind and blindfolded individuals have found that this kind of map, built from touch and movement instead of sight, activates many of the same brain regions normally used for visual processing. Your brain isn't just coping without vision. It's quietly repurposing the exact machinery that vision usually runs and pointing it at a completely different kind of input. So what actually happens if you can't open your eyes for one day? Your brain doesn't just lose a sense. It reorganizes itself around the sense it has left. It hands hearing a promotion. It puts your balance system into overdrive. It starts inventing images out of pure boredom and habit. And somewhere in the middle of all that chaos, it also starts building a second invisible map of the world, made entirely of sound, touch, and memory. One you never knew you were capable of drawing. And maybe that's the real answer here. We assume sight is simply how we experience the world, the default, the baseline. But take it away for even 24 hours, and it becomes clear that your brain was never just receiving the world through your eyes. It was constantly rebuilding it, moment to moment, using every sense you have. So the next time you close your eyes, even just for a second, remember, there's an entire second version of reality your brain is already prepared to build, waiting quietly in the dark for its turn.